All right, we're going to start by talking about right triangle trig. And the first thing we want to do is make sure that your calculator is in degrees. So go ahead and grab your calculator while I pull it up on the computer. All right, so to the right of this second button, you'll see this mode button. If you click on that, the fourth one down, you'll see that there are radians and there are degrees. You want to scroll down, and if you want radians, you'll hit enter and radians will be highlighted. But right now we want degrees, so we will make sure degrees are highlighted. We will be talking about radians later, so make sure you know how to switch your calculator from radians to degrees and back again. All right, so now that our calculator is in degrees, sorry, let's go back and talk about the sine, cosine, and tangent. So here we have some angle, we'll call it theta. This theta is usually used as a variable for an angle. And the sine of theta is defined as the side opposite theta over the hypotenuse. So the side opposite theta is the one that's furthest away. So if you take a look at this one here, this side here is furthest away, so it would be A, and the hypotenuse is C. The cosine of the angle is the adjacent over the hypotenuse. Well, the one that's right next to the angle is B, so the cosine of theta would be B over C. And the tangent is defined as the opposite over the adjacent, so it would be A over B. Now, there's a little story that helps you remember your sine, cosine, and tangent ratios. And it's about a little Indian boy who didn't have a name. So he went out into the woods, and he was all alone and mad because he didn't have a name. So he kicked a rock. And when he kicked the rock, he hurt his toe. And in order to cool off this poor hurt toe, he went over to a stream and he put his foot in the stream. And the rest of the Indian tribe saw him. And so they said, I know what we'll call you. We'll call you Sokotoa. So this is a way to help you remember that S stands for the sine, O for the opposite over the hypotenuse, C for the cosine is the adjacent over the hypotenuse, and T for tangent is the opposite over the adjacent. So let's see how we can use this to find some missing side lengths. So if you use the Pythagorean theorem, you need to know at least two sides of a right triangle in order to find the third side. But when you're using trig, you only need one side and one angle. So here, this 35 degrees, the side that's labeled 6 is opposite the 35 degrees, and the side that's labeled x is the hypotenuse. So if I'm looking at what uses the opposite in the hypotenuse, that would be the sine. So I can set up a ratio. The sine of 35 degrees is x over 6. I can cross multiply, and I have x sine 35 is 6. And if I divide by sine of 35, I'll get 10.5. Let's go to our calculator and see how that works. So I'm just going to go to 6 divided by the sine of 35 and hit enter, and you'll see, in fact, it is 10.5. All right, now if I say find the cosine of an angle, but I want you to leave it as a fraction, all right, so here I have the angle. Well, I have the opposite and I have the hypotenuse, but if I want to find the cosine, I need the adjacent. But I have two sides of a right triangle, so I can always use the Pythagorean theorem to find the third side. So 9 squared plus b squared is 13 squared. If I solve this for b, I know that b is going to be plus or minus 2 square root of 22. But since I'm talking about the length of a triangle, I can throw out the negative answer and just keep the positive. So I know that this side is 2 times the square root of 22. The cosine is the adjacent over the hypotenuse. So it'd be 2 square root of 22 all over 13. That's what the cosine of the angle would equal. You can use trig in order to solve some word problems. A builder constructs a ramp over an existing walkway. The ramp makes a 15-degree angle with the ground. If the length of the walkway is 32, how long is the ramp? Well, it's especially helpful to draw a picture. You know it's going to be some sort of a right triangle. The ramp makes a 15-degree angle with the ground. you have the walkway, and there's your ramp, and there's your 15 degrees. You know the walkway is 32 feet, and you want to know how long the ramp is, so that's what your x is. Well, if this 15 degrees is your angle, the walkway would be your adjacent, and the ramp would be your hypotenuse. So therefore, you're going to use the cosine. So you can say the cosine of 50 degrees is the adjacent over the hypotenuse, 32 over x. Again, cross multiply, divide by the cosine, put that in your calculator, and you'll get that the ramp has to be 33.13 feet. Now, there are three other trig identities that you'll need to know. One of them, the first one is called the cosecant, and the cosecant is defined as 1 over the sine, which would then be the hypotenuse over the opposite, and it's abbreviated as CSC. The next one is the secant, which is 1 over the cosine, which then would be the hypotenuse over the adjacent, and it is abbreviated as SEC. And then you have the cotangent, which is 1 over the tangent, which would be the adjacent over the opposite, and it's abbreviated as COT. So if I say find all 6 of the trig functions for this particular triangle, well, I know 2 sides, but I need to know the third side in order to find all 6. So I'm going to have to use the Pythagorean theorem. When I do that, I know C is plus or minus 74, but again, it can't be negative, so I'm going to throw out the negative answer and keep the positive. So now I know that I have the sine of the angle. The sine of the angle is my opposite over my hypotenuse, so 70 over 74, and you're going to reduce that fraction to 35 over 37. The cosine is your adjacent over the hypotenuse. Reduce that fraction, so it's 12 over 37. And then the tangent would be the opposite over the adjacent, so 70 over 24. Reduce it to 35 over 12. Once you have these 3 trig functions, the other 3 are very simple. The cosecant is 1 over the sine, so you just take your 35 over 37 and flip it. The secant is 1 over the cosine, so 37 over 12, and the cotangent is 1 over the tangent, so 12 over 35. Here's another example. I could say let theta be an acute angle of a right triangle. Find the value of the indicated trig function. So you're given that the sine of some angle is the square root of 55 over 8, but they want you to find what the cosine of the angle is. So the best way to attack this problem is to draw it out. So here is a right triangle. Pick some angle as theta. It doesn't matter. You could have picked the top one or this bottom one. It really makes no difference. But you know the sine is the opposite over the hypotenuse. So the side opposite theta would be the square root of 55. The hypotenuse would be 8. I need to find the cosine, so I need to know what the adjacent side is. But once again, if I have 2 sides of a right triangle, I can always find the third side using the Pythagorean theorem. And so now I know that the third side is 3. Now I know the cosine is the adjacent over the hypotenuse, so now I know the cosine is 3 over 8. You can also use trig to find the measure of an angle. So this is where trig is very important because you can't use the Pythagorean theorem to ever find an angle measure, but you can use trig. So if you have some angle and some triangle where you're given that the adjacent is 3 and the hypotenuse is 8, you can set up a trig ratio. So in this case, since you're given the adjacent and the hypotenuse, you would use the cosine. So you know the cosine of some angle is 3 over 8, but if you want to find the angle measure, you're actually going to solve for the angle, and you're going to have this thing called the arc cosine. So the arc cosine is 3/8 will give you the angle measure. So now again, if you go to your calculator, you see above your sine, cosine, and tangent, you have this sine to the -1, cosine to the -1, tangent to the -1. So I'm going to find the arc cosine. So I'm going to go second cosine, 3 divided by 8, close my parentheses, and it will tell me that this angle is 68 degrees. We usually round angles to the nearest whole angle or the nearest whole number. So anytime you're trying to find an angle measure, you're going to use the arc sine, arc cosine, or arc tangent. And once again, make sure if your problem is in degrees or they're asking you for the measure of the angle in degrees, that your calculator is in degrees. So if you have any questions, please let me know.